Hey guys, Pogo here, and welcome to day 2 of the RPG Game Jam. For those of you that missed yesterday, basically I'm spending 5 days creating a small game live for 1 hour every day. Now if you did miss day 1 yesterday, I'd recommend that you go to my YouTube channel and watch it because we've already done an hour of code and an hour of explaining. So you might get a little bit confused unless you already know what's been going on. As always, I do have the chat open on my second screen, so if you are watching this live and you leave a comment, I will do my best to respond to it. And I believe that's all that we need to get started. So today we are going to begin where we left off yesterday. We're going to actually get the map working. So we're going to just fill in these 4 classes, the location class, the row class, the map manager, and the map class. Then we're going to get the GUI so that it will actually display the current map. And we're really going to go through and do all of that. So the first class that we're going to go ahead and do is the location class. Now I forgot to mention, if you are watching this live or not, I will be posting as we go through the video, uploading what we do to a GitHub repository, which is right here. If you're watching it live, look right below the video you're watching right now, and you will see a link to it. If you're not watching it live, check the description of the video, and you will also get a link to it there. Throughout the video, I'll be posting all of the code so that if you're following along, you can continue to get the latest code and keep working with it. And then after the video is done, if you want to have access to all of the work that we've been doing, you can easily access it from this repository. If you were with me yesterday, you'll know that I had problems with GitHub, but I did fix it and I made that commit, so we're all good and ready to begin. Alright, so the first thing that we're going to do is we're going to write a location class. This location class is basically going to represent a location on the map, or location, yeah, map location, and it's going to contain the tile of the location, so whatever the location, whatever the tile is, and then it's also going to contain the point where it is. So the first location would be at position 0, 0, the second one would be at position, I guess, 1, 0, x is 1, y is 0, and so on and so forth. So we're going to go ahead and declare 2 instance variables. The first one is going to be a private tile. Remember, tile is that enumerator that we made in the last video that just contains, the particular tile that we want to go ahead and render. And then we also need a private point. Now, point is a swing class or an AWT class. Basically, it just contains an X and a Y coordinate and easy ways to access them. So it's the same thing as storing 2 integers called X and Y, but I find it easier when you just have one variable that can contain both things, and you can compare with other points easily and like that. So we're going to go ahead and make our constructor, and this constructor is going to take a string called raw, an int row, and an int column. Now, we're going to go ahead and say this dot tile is equal to tile.byId raw. Now, this doesn't make sense yet because we're kind of working from the ground up. But what's going to happen is the maps are going to be defined in individual text files. Then when map goes through, we read in the map and we, parse each row, and then each row will then parse each map. So each location. So when this gets instantiated, it's going to be, this raw is going to be the ID of the tile. So like if it were an empty tile, then it would just be E, and then we're basically getting it with giving it E. And this will make more sense once we fill in the rest of the classes. Then we're just going to say this dot point, can't type, is equal to new point. Remember, point takes an X and a Y, so we're going to give it the row and the column so that we can easily keep track of the exact row and column where we are. Then we just need a couple of getters rather. Public tile get tile, return tile. That'll be used for when we go to render each location. We need to know which tile to render, and then we need to go ahead and have our public point, get point, return point. So if we want to know the x and y coordinates of the location, we can easily do that with the get point method. And that's all that we need for location right now. So now let's go ahead and check out row. Row is basically just going to, it's basically, instead of using a two-dimensional array of locations with the row and then all the columns, we're just going to have a row class because it just makes it a little bit easier for managing everything. So we're going to go ahead and declare an array list of location, and we're going to call this locations. Import that, and then, okay. Then we are going to take a public row, string raw, and int row. Now, again, we're taking in another string raw, and remember, when we go to define the map, we're going to have rows of IDs. So what we're going to do here is we're going to say string array split is equal to raw.split space. So what this is doing is we're taking this raw that we're given and we're splitting it at the space. So if the raw we were given was just like a bunch of empties, then it would turn that into an array that contains 4 empties. That's basically what we are doing right here. And then we're going to say for int I equals 0, I is less than split.length, I plus plus, locations dot add new location. This is going to take split at position I, then row, and then I. What we're doing here is we're basically going through each individual tile. So if we're given 4 E tiles, we're going to go through each of them. Then we're adding a new location for that. Split at position I, it's just the current I's are counter, and whatever the current position we're at, we're getting that tile. Row is the row that's going to be given when we instantiate it. So like the first row I think would be 0. And then I is going to be, you know, the counter. So in this case, or the column, which would start out as 0. And then for each tile or location, it's a new column. So that's how that works. Then we need to just add a couple of methods. Public location, get location at, int, I guess this would be the row, and then we'll say return locations.get for row. And then this, or rather it would actually be column if we want to make it sense. Okay, so it would actually be at the column, because if I give it the column, then I will have the ability to get, this is the row, so I can get it at the particular column. Then finally, we just want to go ahead and say public location array, get locations. If we want to have access to all of the locations in the row, we're just going to say return locations dot to array, new location array, locations dot size. Now that's a weird bit of code, but if you do stuff like this, you're going to get used to writing it a lot. Basically, we're just putting it in an array, and for whatever reason, you need to declare an array inside of there, or else it'll just do an object array, which is not good enough. So we're just making an empty array of the correct size. Sorry about that, guys. Alright, so that should be good with row. Now let's go ahead and do the map manager. We have the map manager and then the map class. So the map manager is basically going to, it's in charge of reading in all of the maps. Sorry about the phone, guys. Not really anything I can do. But the map manager is basically going to be in charge of reading in all of the maps and then storing all of the maps so that we can get an instance of map by giving it a name. So like if the first map we name is called test, we want to be able to access it by its name so that, you know, when we go to switch maps, we can, you know, have an identifier for the map. So first we are going to go ahead and make this a singleton, but inside of this constructor, we are going to have it actually do something. 1 second. Alright, sorry about that, guys. It was the house phone and I needed to get it. But as I was trying to explain before, Map Manager, we know that it's going to read in all the maps and give access to it. Okay. And right now we were in the middle of making it a singleton, so we can access it from anywhere. Private static Map Manager instance is equal to new Map Manager public static Map Manager get instance return instance. Okay, so now we have made this Map Manager class a singleton class so that we can access it from anywhere because we want the ability to do that. So now let's actually go ahead and we need to declare a couple of variables in here. First one is going to be a private array list map called maps. Import that. And then a private map current map. To answer the Dark 60 who said, how did you learn Java? I learned a lot of it on my own. I took a 5-day summer class which really got me interested in it, and then I basically took on the initiative and kind of figured it out on my own. For my 500 subscriber special, I did a quick video on my, I guess, history of coding, if you want to call it that. So if you go ahead and check that out, it would probably explain it a little bit better, but that's just the answer to how did you learn Java? Quick answer. So, where was I? Alright, so we have the current map, because we need to know the current map that's being displayed, which is very important. Then we need to go ahead and have a couple of methods in here. Public map get current map, sorry, which will return current map. Then we have a public void set current map, and that takes a map, and then we go ahead and say current map is equal to map, and we could do this dot current map is equal to map. So we're now setting it, and there are going to be some other things that we need to do in there, but not yet. So we can leave that there. Then we're going to go ahead and do public map get map for string name, and we're going to go ahead and say for map m maps if m dot get name dot equals name return m, outside of that loop return null. So what this is basically doing is we pass it the name of the map. It goes through each map, and if the map's name is the same thing, so if I have a map called test, and it's registered as a map, then it would return that map called test, because get name is test and they equal. Otherwise it would return null if it couldn't find the map that it was looking for. So that, I believe, is all that we need as far as methods, but let's go ahead and write the constructor, which is the most important part of, the Map Manager class. This is going to be in charge of reading in all of the maps that we need to have, and then, instantiating a new instance of map for each map file that we need to use. So first we need to just go ahead and say maps is equal to new array list map, because we need to, it's not good practice to instantiate variables in an instance variables. It's better practice to do it in the constructor. So I could instantiate it there, but I'm going to instantiate it up here in the constructor. So now what we're going to do is we're going to have to surround, I believe we need this in a try and catch, but let's go ahead. Oh yes, we do, because we're reading in. So we need to go ahead and surround this in a try and catch. And if we go ahead and catch an exception, we can ignore it because there's no reason why this would have a problem, because we know that everything we're doing in here is safe. So we're going to ignore the exception for now. Now, if something doesn't work right, then we can print out the stack trace just to figure out what's going on. But we don't need to do it normally because we know that what we're doing is safe. So what we're going to do in here, the way this is going to work, and let's go ahead and create some folders so that you'll understand. Inside of the resources folder, we're going to go ahead and make a new folder called map. And then we're going to make a text file called maps.txt. And then we're going to create one called test.txt. Now, maps.txt is going to store a list of all of the maps. Now, you could program it in so that it manually loads each map, but I find it to be possibly a little bit easier to do it like this. So we would just go ahead and type in test.txt. So if you ever wanted to add in more maps, then you could just write them into maps.txt. Now, if you wanted to do it the other way, you could just manually add. You could instantiate new map with the name manually, or you could do it this way, whichever way you want to do it. Test we will fill out when we get to map, but that's going to contain all of the information that the map will need to know. So inside of the map manager, we're going to go ahead and say buffered reader is equal to new buffered reader. Then we're going to say new input stream reader, and then this is going to be resource util dot get instance dot, and we're going to do get resource as stream, and this is going to be map/maps.txt. Make sure to import everything. So what we're doing here is oh, not string buffer. I don't know what it did there. It's buffered reader. Okay. So what we are doing here is we're creating a new instance of buffered reader. Now in Java, a buffered reader will allow you to read from a source. In this case, we're using a file, but it could be, you know, other different types of sources. And the ability of a buffered reader versus a reader is a regular reader. You can only read in one character at a time, but with a buffered reader, it actually has this method called readLine that will read in an entire line for you and then give it to you as a string. Instead of reading in each integer, then casting it to a character and stuff like that. It's no reason to do that. So we have the reader right here, and we're going to go ahead and write a while loop that says while reader.ready not readLine, ready. This method will, as long as there's more stuff to be read, the method will work. So we're going to have each map file on its own line, so it'll just keep doing this while there's another line to read. So then we're going to go ahead and say maps.add new map reader.readLine. Not read, it has to be readLine. So when we read the line, in this case, this while loop would run one time, and it would read in test.txt. Then it would instantiate a new map, and the name would be test.txt, and then it would add it to the list of all of the maps. Finally, we need to close the reader, so we're going to write a statement that says finally reader.close. Oh yes, we need to buffered reader go like that, reader.close. Let's just say it's equal to null. Oh, I see. Alright, so we'll just go ahead and close it inside. Basically, you want to go ahead and close the reader because you don't need it to be open and using up resources. Normally, you would do it inside of a finally statement. What a finally statement does is it says whether try runs fully or catch runs fully, it will always do the finally. So even if an exception happens and the catch block runs, finally will still happen. So it's just a good thing to know, but we'll just go ahead and close it. I guess it's safe to close it in here because, you know, it wouldn't really work if there was an error. So we're okay. Then we want to go ahead and call set current map to maps.get0. Now this, depending on the implementation of the game, and we might change this later, or if you decide to use this framework, you might change it. We don't want to have the null map, because then when we go to render it in the GUI, it'll be null, and we don't want that. So I'm just setting it to the first map in that list, but of course you could go ahead and change it if you wanted to change it to however you wanted it to work. So that is all that we need to do for the constructor. It just reads in a list of all of the maps, and then instantiates a map for each one, and then sets a current map to the first map that it found, basically. Now we're going to go into the map class. Now, as I said, the map class, we have these getters and setters already defined, but the constructor needs to be filled in. So first, of course, we need to instantiate rows to be a new array list of row. Then we're going to do basically the same thing. Let's just go ahead and copy this because it's very similar what we're doing. Now in this case, we are going to change a couple of things. Instead of being maps.txt, it's going to be the name. So if the name is test.txt, then it would get test.txt inside of the map folder. So that's exactly what we want to do. Now we don't need this while loop because, well, not yet actually. I think we will end up using it. Now, before we continue, let's go ahead and actually write out what the format is going to look like. The first line is going to have the name of the map. So in this case, it would be test. The second line will have to be the type of the map. So if you go ahead and look in map type, you'll see that the only option is outside, so we're going to call it outside. Now it's important that you write it in all caps because otherwise it won't work. So you need to write it in all caps. Now the next part is important because this is where, or actually one thing that we need before that, we need to know the spawn of the map. So like when the map is loaded, where does the player go? Now, this might end up being removed or not always used because if a player enters a map, then if they enter the map from a location, like if they walk up to the top of the screen and then it loads the map, then they should appear at the bottom of the screen. The program should determine that. But if you're like, walking into a door and entering a house, then you need to know where in the house you should get spawned pretty much. So you may or may not use this at least all the time, but we are going to go ahead and define this with the row and the column with the space in between. So we'll do 5 space 5. So that is, the spawn will be 5 5. And again, you might not always use this. You do always need to define it, but you might not always use it. And eventually as we get further in, we'll see. Nothing is permanent and stuff in this code is subject to change. Now finally we're going to go ahead and actually define the map. So the way that we're going to define it, as I said in the very beginning, which might have been a little bit confusing because we hadn't gotten very far, is when we made that tile enumerator, each tile was given a unique ID. Empty is E, grass is G, water vertical is WV, and water horizontal is WH. So each tile has its own ID. And we're actually going to write out the map in this way. So let's just start out with an empty map, and then we can just go ahead and quickly add in a couple of things to demonstrate that it does work. So remember, each map, if you go ahead, and I guess we probably didn't define that in constants, but we will go ahead and define in constants that we have, we need to define that the public static final int, so we have num rows is equal to 15, we have 15 rows, and then tiles per row is equal to 20. There are 20 tiles per row. Tiles per column is equal to 15. So there are 15 rows. Each row has 20 tiles, and then tiles per column. Each column down will have, and I guess we probably don't really need that because we're just saying we have 15 rows across, and then each row is going to contain 20 tiles. So we're going to go ahead and write this out. We're going to write 15 rows of 20, and remember each ID is separated by a space. So we're going to just declare a line of all empty. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That should be 20. Let's just quickly count. 1, 2, 3, 4, 5. Alright, so that is, in fact, 20, and we're good. So this is just one row of empty tiles. So now we need to go ahead and copy this, I guess, 14 more times since we have a total of 15 rows. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So now we have a grid of 15 by 20 E's. So just to demonstrate, let's just go ahead and throw in a couple of waters in random locations. We know that grass is going to be the background, so I can't really add grass. You wouldn't really see a difference. But let's just go ahead and do a water vertical right there and a water horizontal right there. Just throwing them in at random places just to demonstrate that it does work. So that is what the format of the map is going to look like. So now we need to take the map and have it actually recognize that format and then parse based on that format. So let's go ahead and first say this .name is equal to reader.readLine. So the first line is the name, so we can just go ahead and read the first line and say that it's the name. We can go ahead and say this .type is equal to mapType.value of reader.readLine. We know that the second line of any given map is going to be the type of the map, so we can go ahead and take the next line and get the value of it as a map type. Now, when I said that it's important that you have all uppercase, that's because map type defines outside in all capitals. So if you wrote it in all lowercase in test.txt, then it wouldn't be able to find the outside in all caps because it is case sensitive. So you need to make sure that you do it in all caps. After that, we have the spawn. So we're going to go ahead and say string spawn line is equal to reader.readLine. So this spawn line is just the line where the spawn is, and then we need to get the row and the column. So we're going to say int spawn row is equal to integer.value of spawnline.split space at position 0, and then we can copy this for spawn column, and it's going to be at position 1. So what we're doing here is we are saying we're getting the line where the spawn is, then for the row and the column where this value of method in integer is taking the string and then finding the integer inside of it and then converting it. So in this case, since row and column are both 5, the string, like the first before the space, the first string before the space is 5, so then it evaluates to be the integer version of 5, and then we know the row and the column. Then we are going to go ahead and say we need to go ahead and define an int I is equal to 0. Then we're going to say while reader.ready rows.add new row reader.readLine I++. This is sort of like a for loop, except we don't know how many lines there are going to be. I guess we kind of do, but it's just easier if you don't hard code it. So basically, we're keeping this counter for the number of rows. So the first time it runs, row will be 0 because we need to know, the x position or the number of each row. So then we go ahead and read in the line so that we have the next line. And then I++ is basically, it's passing it I, and then it's adding 1 to I. It's the same thing as writing I, and then under that writing I++. It's just, easier notation for doing the same thing. Then we're going to go ahead, and we're almost done. This .spawn is equal to getLocation, spawn row, spawn column. Now we haven't written this method yet, but now we actually can write the method because we have defined everything in location and row and whatever. So let's go ahead and do under getType. We're going to do public row get row int row. Then we're going to say return rows.get for row. So that's just an easy access to getting the row that we want. Then we need to go ahead and say public location get location int x or int row int column. And then we are going to say go ahead and return rows.get for row dot get location at column. So this is just shorthand of saying get row for the number dot get location at, then giving it the column. It's just an easier way to do it, and it does make a difference when you're writing out long lines of code, and it's just easier to do. Then we're just going to write a little utility method. It does the exact same thing, but it just takes a point, and it just returns get location for point dot. We got to import it. Okay, there we go. Point dot x and point dot y. So there we go. So now we have get location. You can give it either a row and a column or a point. It's just an easier way to do it. And you'll see that the get location thing goes away. Now the reason why we couldn't declare spawn up here is because we didn't have any rows instantiated yet. So then get location would not have worked. It would have thrown, I guess, an index out of bounds exception or whatever. So we just needed to do it once all of the rows and locations have been established. Alright, so I guess that's all that we really need to do for the map. Seems like everything's good, but we'll, of course, have to just find out. Now we're going to actually get the map to render. We're going to write the GUI so that it takes the current map and it will actually display it for us correctly. So, we already have our GUI class set up right here. Again, I explained yesterday, it's a JPanel, which is a class of swing. We're overriding this pane component method, which will, this is where we're going to do all the drawing. This graphics instance called G will contain methods for drawing images, drawing text, drawing shapes, all the different things that we could ever possibly need. And that's exactly what we need to do. So first we are going to go ahead and write we're going to use a little game loop in here. If you don't know what a game loop is, it's basically where the game will continue to run for a set amount of time, or every so often the game will re-render itself. So if you've ever seen FPS or frames per second, like I think the standard is 60, then that means that every single second the game re-renders itself 60 times. So we're going to go ahead and write a loop that makes sure that this happens, 60 times a second. Now this is just a little bit of a lazy loop, but we might end up changing it later if I find out a way that works better, or if this way just doesn't work correctly. So inside of the GUI method, we're going to go ahead and instantiate a timer. Timer t is equal to new timer. It's going to take 1000 divided by 60 for 60 times a second. Then it takes a new action listener. And then we're just going to go ahead and call the tick method. Then we need to go ahead and say t.start. So one important thing to note is that this timer is not java.util.timer, it's javax.swing.timer. If you use the util version, then it will not work the same way as this one, and you might get confused. So make sure that you're using the swing version. It takes the number of seconds in the delay, so it'll delay for that number of seconds before running. This action listener is just basically when it's time to do something. We're going to call a tick method that will basically represent, one tick, and it'll handle input eventually, and then it'll also do the repainting. So we're going to go ahead and define that in a second. Now we have t.start, which will go ahead and start the timer. Now, by default, it will repeat. So you can actually set repeats to be, true or false, but by default it will repeat, and we do want it to repeat. So we're going to go ahead and write a private void called tick. We're going to make it private because we only want to be able to access it from that timer, so it can be private. And the tick is basically going to be check input. Once we get the player done, and I guess probably we're going to do the player in the event system first. Or no, I guess we'll do player and then input and then event system. So once we get there, we'll have this input be running because we need to just be able to handle when the player presses a key, but it can't just be whenever they press a key, do what they want as soon as they press the key. We need to make sure that it stays in sync with the game, or else there could be some confusion. So we'll get to that later, but we're going to handle the input inside of tick. So 60 times a second, it will handle the input. So no choppiness. As soon as you press a button, the input will be handled pretty much. And the only other thing that we need to do in here, other than check input, which we'll do later, is call the repaint method. Now, the repaint method is defined by swing, and it's inherited from jpanel. So this class is a jpanel. It contains this repaint method. Repaint indirectly calls paint component. So 60 times per second, tick is going to be called, which first checks for input, but then it calls repaint, which indirectly calls this. So this method is going to be called 60 times per second, and this is where we're going to go ahead and draw all of the tiles and the player, and I guess any of the other entities like NPCs or whatever is going to show up there. And one thing that I forgot to mention is if you go over to layer, you want to add one more layer called background. That layer just represents the background layer, and you'll see why in just 1 second, because now we're going to have it actually draw the different pieces of the map. So we're going to go ahead and write a method called drawTiles, because we're going to be calling this 5 times, one for each layer. And rather than copy and paste the same thing 5 times, which would make no sense, we're going to go ahead and do a private void drawTiles. It's going to take a graphics G, because we need to have graphics for doing the drawing, or else, nothing that we can do. Then it's also going to take the layer. So we'll pass it each layer manually, so we'll say, first draw it for the background layer, then the layer below, then on, then entity, then above, and we'll get there in a second. So this is basically going to go through and draw all the tiles that belong on each layer. So now I'm going to go ahead and say for int, because we're going to start with j here, is equal to 0. J is less than constants dot num rows. So this counter represents the number of rows in just the number of rows on any map. Then we're going to go ahead and say row is equal to map manager dot get instance dot get current map dot get row for j. So we now have the correct row that we're looking for. Then we're going to go ahead and say for int I is equal to 0. I is less than constants dot tiles per row I plus plus. So this is going to be called for each tile in the row. So inside of here, this method is going to be called one time for every single given tile. And each time there's a different row, we will have access to this row right here to do all of the work that we need to do. We're going to go ahead and say location lock is equal to row.getLocation at I, and import location. So now this location represents the current location. This will be called again one time for every single tile that's supposed to be rendered on the map. So we'll have the location for each, which remember gives us access to those get point and get tile methods, which are very important for knowing which tile to draw. And I guess we don't really need to use the point here. We'll use that in other locations. Now we need to go ahead and do a couple of checks. So if L is equal to layer.background. So if we're supposed to draw the background layer, then we want to go ahead and say g.drawImage. You'll see that we have this drawImage method, and it's going to take, we're going to use the one at the very top that has 4 parameters. So we're going to go ahead and say g.drawImage. This should take map manager get instance get current map get type get tile get image get image, and let's just go ahead and make this easier to read like that. So first, we're drawing the background, we're getting the background image for the current map. Then the X and the Y position that we're drawing it is going to be I times constants dot tile width, and then I times constants dot tile height. So what's going to happen is the first time this runs, I, and that's supposed to be J, I will be 0 and J will be 0, so it'll draw to position 0, 0. Then next time when it's 1, then when it gets to be 1, 1, it'll draw it at position 32 by 32. This ensures that it gets laid out properly without overlapping anything. Then finally, it wants the image observer, and we can give it this because, it's supposed to be if. Because we, because J panel is an instance of image observer. That's not really terribly important. I don't know if you even need to give it anything. So we're just drawing the background image there. Then we're going to go ahead and say if L is equal to layer.entity, and then this is where we're going to draw entities. So we're going to go through, the given location, and if there's an entity at that location, we're going to draw it, but we're not going to get there until we, of course, define the entity and then the player and, whatever, stuff like that. So we will get there eventually. Then finally we can just go ahead and do the else statement, because we don't need to do anything else special. If it was background, then we need to use the background tile. If it's an entity, we draw the entity, but otherwise we don't need to do, we can just say if lock.getTile is not equal to tile.empty, because remember, we don't want the empty tile. First of all, we don't want to draw anything, and second of all, there's no image defined for it, so it would throw a null pointer exception, I believe, if we try to use it. And then we also need to say if lock.getTile.getLayer is equal to L. So basically, we're saying that if the tile at this location belongs on the current layer, then we can go ahead and safely draw it. And you're going to want to copy this code, but instead of map_manager.getInstance, whatever, we're going to say lock.getTile.getImage.getImage. And remember, we're making two image calls, but the first one will return an image icon, then this will return an instance of image, which is what we actually want. And otherwise, everything should be good there. So that is the draw tiles method that will basically take in a graphics and then a layer, and then it'll draw based on what the layer is. It'll draw everything correctly. Then inside of this draw map method, we're going to go ahead and call draw tiles a couple of times. So we're going to pass it G always. Then we're going to call layer.background. Now we're going to do this in the reverse of how things are going to show up, because we want things to be drawn on top of each other. So first is the background, then there's below. So if there's something on the layer below the player, then it needs to be on top of the background. Then if there's something on the layer of the player, it needs to show up above the whatever's below it, then entity, and then above. So if there's something above any entity, above the entities, then it needs to overlap the entities, and we want to go ahead and do that last. And that should be good. We do have our draw tiles method, and we're ready to test this out. I highly doubt that it'll work the first time. I'm sure I made some typo somewhere, but here goes. If this works correctly, it should render that test map exactly how we wrote it out. Here we go. Alright, getting ready. And we get lots of errors. Good. I was not really expecting it to work, so let's go ahead and do a little bit of debugging. So, first of all, it looks like we're getting an array, and we're getting an index out of bounds exception when we try to get the row. So let's just go ahead and debug this. Debugging is what you'll spend most of your time doing when you are writing code. So first, let's just check the GUI draw tiles and make sure that there's nothing wrong there. Get row for J. Rows. And number of rows is 15, so that's good. So that should not be an issue, but it is showing up right there. So let's go ahead and try printing out let's see, let's just do map manager.getInstance.getCurrentMap.get rows.length. So we just need to quickly write this. What I'm going to do is I'm going to make sure that it's actually getting all of the rows. So we're going to print out the number of rows that actually appear that are there. So let's see if it's actually working. Public row array get rows, return rows.toArray, new row array rows.size. Confusing line of code again, but gotta have it. So that's good. let's just go ahead and comment out repaint from the tick method, because the problem was it was calling paint component 60 times per second, so we got spammed with those stack traces. We only wanted to call it, I think it'll call once or twice when it first loads, so then we can actually take a look. Alright, so it looks like we are getting that there are 0 rows being loaded for the current map. Let's just go ahead and see that it's getting the current map is not a null map. And it is not. So we are getting the correct map. Now if we go ahead and check out test, does look like we are doing fine there. So let's go head over to the map class, because that is most likely where the issue will be. So here's the map class, and give me 1 second. Okay, map class open. Let's just go ahead and say string line is equal to reader.readLine. Then we need to print out the line, and then we of course need to change that to use line. So now we're going to go through and have the map print out each row that it's given to make sure that it does in fact print out a bunch of rows. Okay, so it only runs once, and it gets all of those E's. So it looks like the issue is that it is only running one time. Let's just make sure that that is... Hold on 1 second. Let's just make sure that that is the end. I don't know why that was doing that, but let's just make sure that it does only in fact read one row. If it does, then that's quite odd. Now where does it get to be done? Aha! Alright, so we know now that the error is occurring somewhere inside of this loop. Hope you guys are having as much fun as I am debugging this, but now we know that the error is going to happen somewhere inside of this row. We're going to go ahead and, let's just go ahead and print out split at position I. So we'll just see that it's going through each tile, because if this only prints out one time, then we know it's an issue inside of location. Oh, I think I see the error. So this... we found the error. The issue was that locations was never being assigned to a value. So when we tried to add something to it, it was null. So let's see if it works now. If not, we'll get a different error. Okay, so it certainly does something. It's very interesting. Alright, so now it's actually, of course, rendering everything correctly. So let's go ahead and remove all of that debug. But it looks like it's having an issue, I'm guessing, inside of the tile enumerator with this. Oh, and I remember what the issue is. The issue is we forgot to add these -1s. What I decided to do for this is, rather than saying at position 0, 0, let's just have it show at position 1, 1. So it's just easier to read that it's at 1, 1, but then in the constructor we subtract 1 from each, so then it'll get it at position 0, 0. But it's just easier for us to read that it is at 1, 1. So now if we go ahead and run this, it should work. Here we go. Alright, we finally did it. As you can see, it rendered the map 15 by, I guess it's 20 long and 15 tall. The map did successfully render, and it has the, I guess that would be the vertical water right there, and the horizontal water right there. So it clearly did read in, all the empty tiles, which it skipped, but then those 2 tiles where we gave it specific IDs, it actually did read those in correctly. So now we have the map actually loaded. So what we did today is we read in a list of all the maps that we need. Then for each map that we needed to go through, we parsed the map file, and then we got it to display the first map, or the test map that we made, and it did successfully display it. Now you don't see it, but, and actually before I commit this, we need to fix that. In GUI, we need to uncomment that repaint, and now, let's run it again. Not that you'll notice a difference, but this is, right now, this image is being repainted or redisplayed 60 times per second, which is definitely very impressive, but not so much for a computer. When we add the player and we add a very basic walk cycle, then this is going to be important so that it's not, so that it doesn't look choppy, it looks like a smooth animation. So of course for this, nothing's really going to change about the environment, but when we go ahead and add things that move, you know, players or possibly even NPCs, then it's going to be important that it keeps updating so that it'll continue to get the correct image and the correct location for all of the different entities, and that will be important. I'm going to go ahead and stop the video now. I know that we are 8 minutes under the hour, but it's not worth starting anything new. Next time, I believe we are going to go ahead and add the players, and after that, we'll add players and input, and then after that, we will go ahead and I think work on an event system, and then there are some other things we can do, like have something where you can actually, you know, like a sample where you can walk around and, you know, interact with a certain person, and then, you know, move from one map to a different map. So that's all for this video. I hope you guys enjoyed. Same time tomorrow, 4 o'clock my time, for part 3. Again, this video will go on YouTube, and I'm going to go ahead right now and commit all of these changes that we did today so that you can access all of the code. So this is everything from day 2 with all of the different changes. Let's go ahead and commit the code and push it. And this time we're not going to get the issue because I did fix it. And if you go ahead and take a look, you'll see that the GitHub wiki, or I'm going to say wiki, the GitHub repository is now running. So are there any questions before we go ahead and end? I'll give this a couple seconds to catch up to the people who are watching live. If you have any questions, leave them in a comment, and I would be happy to answer them. If anything in this video confused you, please make sure to let me know. And if you're not watching this live, you can always leave a comment below, and I will respond to it either in text form or in the next episode if it's an issue or a fix or something that I could do to improve the video. Alright, got one question. Do you know Ludum or Ludum Dare? If so, will you attend it? I don't know what it is. If it is a game jam, which I think it might be, then I would look into it. Probably not, but I would look into it. No, I don't think I know what it is, but I'll check it out if you think it's interesting. That was Jack's 9123, by the way. And I think that is all that we are going to do for today. Thanks for tuning in. I hope to see you guys tomorrow, and see you soon. Bye.